Howdy, pre-calculus. Today we're going to be going over graphing techniques and the algebra of functions. And algebra of functions is just basically how you can combine different functions and such. So before we get to that, we're going to get into graphing techniques. And so for the graphing techniques, we're going to first go over the horizontal displacements, right? And so what is the horizontal displacement? What's this little h naught? You know, you've got right there. Where you've got a general function, you know, like an f of x, but note that we have this f of x minus h naught. And so anytime you see this minus something, well then it's going to be a displacement to the right. It's a little bit opposite to the way you might think, because you think minus, you think left, but that will not be the case here. When you see a minus for the horizontal displacement, it means you move to the right. So let's go ahead and identify the horizontal displacement here. We see that it is a 2. And so let's go ahead and figure out what's going on. First thing we know, since we're moving this over to the 2, we're going to go ahead and create what I'm going to call a virtual axis, right? That's our new virtual axis. We're going to call that y prime. And the prime just means it's a different axis. It doesn't mean anything special beyond that. So just different axis. Our x-axis is still the same. So what we're going to do is we're going to look at this function here, and we're going to go ahead and just map it onto the new axis. So first thing we note is that, it passes through the origin, right? This point corresponds with this point. And then we look at this point here. And that's about, 1/2 to the left. And so we're just going to come on over here and put it right there. All right? And then next we take a look at this point here, right on the origin, like it's two units to the left of the axis. And so we're going to go, 1, 2, and that's going to end up right there. A little confusing since it does overlap with that point, but we'll go ahead and take these away so you don't get confused. Alright, so right here, next we have this point, not quite 3 units up, not all the way up, and so we're going to put this, 3 units to the left is here at -1, and we're going to put that right there. So that's how that goes. And then from here, it's a simple game of connecting the dots. I'll go ahead and use a different color here to connect them. And we're going to try and just make it look as much like the original shape as we can. We are only just hand drawing this after all, so it doesn't have to be perfect. But we want to make it look reasonably close. Alright, so that's that one. Now look at this one. Note that we have a plus here, right? But usually we've got a minus. We want to make sure we get this in the form we're familiar with. So this is the same thing as f of x minus -2. Right, so -2 is our horizontal displacement. So again, we're moving it 2 units to the left. Alright, so let's go ahead and draw our virtual axis. This time we're moving it 2 units to the left. We're calling it y prime. Alright, and then we're just going to move everything over. So let's kind of look at some, the extreme points. It was like the points that kind of make sense to move over, shall we say. We can see that, it passes through the y-axis just below the origin, so about right there. Again, we're moving everything 2 units to the left, so this point goes 1, 2, right there. And that point of bend, now that's going to be, 1, 2, about right there. Okay, and this extreme point right there to the left, that gets pushed over 2 units. So we'll put them right there. Let's connect the dots so that we have this guy right there. Alright? Good. Alright, so let's look at the other one. Again, let's look at the extreme points. That's at 3. It's being moved 2 units to the left. I'm sorry, 2 units to the left. the 3, so get us at 1. We got this bendy point right here at about 1.5. So we come over 2 units, put them there. And then of course we have this extreme point here. Looks like it's right before the 1, so we'll put them right there. And then we connect the dots. To get something like that. Alright, that's how we do it. That's how we handle the horizontal displacement. Why don't we go ahead and take a look at Desmos for a more interactive example. And you can see here we have a function already at our disposal. F of x equals x times x minus 3. Alright, so let's go ahead and graph this next guy. So we're going to go and say, well, what if y equals f of x? Say minus 1, so we shift everything 1 unit to the left. And let's go ahead and change the color so it stands out a little bit more. And we'll make the original function be dash so it's even more obvious. Alright. And so you can see here we've got everything shifted to the right by 1 unit. That's because we're subtracting 1 from here. And so note this is still in line with our new axis. And so if we were to graph a new axis, put it right here, x equals 1, that's our new y axis. And you can kind of see how everything lines up there. Let's go ahead and make this right there so you can kind of see the new axis. And so this is our new virtual y prime axis. And so we note that starting point here on the original function corresponds with the starting point right there. Alright, let's go ahead and add a little interactive component onto this. We'll make this a variable. We'll add a slider for a along with the new axis. And so kind of note that, you know, let's go ahead and set some new bounds for this one. Alright. Alright, so now while, you know, A is positive, you know, we're shifting up because right now we're subtracting, like right now it's 2.5, we're subtracting 2.5, and we see how this guy is moving up to the right, you know, as we increase that number. And as we bring it back down, and we bring it to 0, we'll note that, you know, 0 means that there is no displacement whatsoever. F of x minus 0 is just f of x after all. But now we're going to switch to a negative. And what does this negative mean? What is it doing? This means we're going to have x plus 1.4, right? Because we have minus and negative. Kind of like how we did with the second example that we worked at just a minute ago. And we can see it just kind of moves over there like this. And you can just see how it just shifts according to whatever that value of A is. Okay. Alright, so back to the handout. And now we're going to move on to vertical displacement. And vertical displacement is exactly how you would expect it to be. If you add a positive number, then you're going to shift it up. If you subtract a number, then it's going to go down. Kind of just the opposite, whether it's when it's inside the function. And it's going to be kind of a common a theme for this lesson is that when it's inside the function, it's a little bit opposite of what you might think, but if it's outside the function, it's exactly what your intuition would tell you. So here, your intuition tells you should shift it 2 units down, and that's exactly what you should do. You're going to be shifting it 2 units down, and in this case, our k-naught value is -2. Alright, so let's go ahead and do our virtual axis down. Our axis is getting shifted down by 2. And so when we do that, you know, we go 1, 2, and then we draw our new x prime axis. You know it's x prime because we're shifting down. If it were the y axis that we're shifting, we'd be shifting left or right. Okay, so go ahead and do one more. There we are. Make that look nice. And now we're going to go ahead and just shift all the points. We kind of look for just, you know, what key points. And key points are just points that kind of catch your eye, you know, turning points or end points, you know, anything that helps you draw it better, right? This is right now it's more of an exercise in art when we pick which points are, but you know, the actual motion that's going on is very mathematical. So here we're up 2, so this is going to go down to the old axis right there. Alright, so now we simply connect the dots, and we have ourselves a nice shifted function there. Alright, and so in this one, you know, we have +2, so you know, we are going to be shifting up by 2 units. And so we're going to do our new axis 2 units high. And we're going to call that again our x prime, where the prime in this context simply means a different x. Nothing special about the x, it's just a different x. Alright, and then we just pick our key points. This one looks kind of nice there, so we're going to put the new one there. This one's good here, so we'll pick this one up, and again we're just pushing each point up 2 units. So we look at this one, and we'll put that one right on the new axis, and then we look at this guy. This is going 2 units up, so we go 1, 2, and it goes right there. Okay, let's go ahead and connect the dots here. And there we are. That's it. Our shifted function. Every point should be shifted 2 units up in that one. Let's go ahead and take a look at Desmos now. Alright, so again we've got our original function right here. You can see how it's flowing. And now we're going to look at what happens when we add a k-naught here on the outside of the function. Before we do that, let's go ahead and just look at a specific number, and then we'll put ourselves up to the general case. We just add 1. And we note the function gets pushed up by 1. Add 2, it gets pushed up by 2. Or if we subtract, say, 3, well, then it gets shifted down by 3, just as we were observing earlier. So let's go ahead and switch this back to the arbitrary k-naught. And you notice that as k-naught is positive, what it means we're adding, this function's getting shifted up. And when k-naught is negative, it's going back down. Alright, let's go ahead and put on our simulated axis there as well, and you can see it moving right along with it. Okay. Alright, so once again, back to the handout. We've handled horizontal and vertical shifts. Now we're going to move on to stretching. So now we're at a section where we're talking about vertical stretch. Alright. So now we have a number out in the front. So this is going to be a vertical stretch. And I know I used A for the first Desmos example, but we're going to use A again here. Just make sure you're aware of that. Look right here. We note we're stretching everything out by 2 units, right? And so that means everything's being pulled away from the x-axis by a factor of 2. So let's go ahead and take a look at this. You note that right here, this has a value of -1. So that means we're going to be multiplying it by this guy here. So -1 times 2 is -2, right? Where everything's getting multiplied by 2. And then you look right here. That's about half. Well, half times 2 is 1. So that guy's going to go right there. And now look at this one. That's close to a half. Probably not. Well, maybe right at a half. But we'll just we'll put the new point about right there. Okay. And so everything, just just double the distance. And so here, that's at -1, so that gets down to -2. Right, everything is just times 2. And then right here, that one, 1.5 units down, so we're going to go all the way to 3. and then this one to here, and it looks like that's pretty much what we need. So let's go ahead and connect all the dots. So note how it's just getting stretched out, and note, I want to bring your attention to this point here. Note that they both go through the x-axis at the same point. Why is that? Well, what is 0 times 2? That's right, it's 0. And so that's why they both share the same point right there. And then they also, didn't draw that quite right. Let me fix that. It's got to go through with this. Let's see if I can do a little bit better. There we go. And then let's go ahead and redraw those. There we are. So they both go through the origin at the same point. And then again, that is because the output of the original function is 0, and then 2 times 0 is 0. Alright, so let's go ahead and take a look over here at this next one. And we see a 1/3 out in front, so that means our vertical stretch is a 1/3, so that means it's not really being stretched, it means it's being compressed. Right? Everything's being brought in towards the x-axis by a factor of 3, right? It's 1/3 the distance. And so we look at this point right here. That's -3. Well, what's 1/3 of -3? That's right, it's -1. So it goes right there. What's 1/3 of 0? Well, that's just 0. And then we're going to look at this point up here. And can't, just by glancing at it, it's not immediately obvious, but we're just going to eyeball it and say, you know, about, that looks like that's about 1/3 the distance. And let's go ahead and connect those points, and there we have it. Alright, so we're here in Desmos. We're using the same function that we've been using before, and it's just kind of a random function. But note that, you know, on the stretched function we have the a hanging out here just like we did in the handout, and note that as a increases, you know, note that, you know, this guy here is growing up, this guy is staying stuck to the axis here and here, and just also note that, you know, it might be kind of harder to see these points down here, but you can note that, you know, you note that the blue is shooting downwards faster and faster relative to the original function right here. You can kind of, as you see it growing, it becomes more and more, and then as it comes back down towards 1, it's going to approach the original guy itself. Alright, so kind of look at the whole thing, you know, going back and forth. That's, you know, pretty much how it goes. Note that I've restricted A in this case to be between 1 and 3. Let's go ahead and take a look at it when we restrict A to be in between 0 and 1, right? So now it's, think of like 1/3, you know, or a half. You know, these are all in between 0 and 1. And note what happens as we get closer to 0. Now it's shrinking down. So anytime you see a number in between 0 and 1 in front of the function right here, you're going to be compressing the function back down towards the axis, like so. Alright, just a quick animation of it going down like that. And also note what happens when a equals 0. Note what it does to the function. It lays it out into a straight horizontal line. That's because all the real numbers that this function is outputting are being multiplied by 0 in this case, and anything times 0 is just 0 itself. Alright, so there's one other thing that we haven't looked at. We haven't looked at, well, what happens when a is less than 0? Let's start off with just -1, I think, because that clears it up. Note how when it's -1, we just have a nice reflection going on across the x-axis here. Alright, that's what that does, and, you know, if we were to stretch this out any, And then we would sorry. There we go. As we go further down, it's got the same effect. What does that negative do? It just reflects it downward into the other half, right? And so that's how that is affected. All right, so back to the handout. We've handled the vertical stretch, and now we're going to look at the horizontal stretch and shrink. And so now note the placement of our letter. It's right in front of there. And now note that, importantly, that the horizontal stretch is 1 over that number, right there. And once again, that is the horizontal stretch factor. So we're going to look at here. We've got 3. So what's the horizontal stretch factor? Well, we're actually going to be compressing it by 1/3. All right. So basically, everything that was far out is going to be brought in by a factor of 1/3. So this was originally at -3. So we're going to multiply that by 1/3, putting it at -1. And then look right here. This was at 3. We'll multiply that by 1/3, and that brings it into 1. And of course, right here, 1/3 of 0 is just 0 itself. And so there we are. We bring it in just like that. All right, that is the horizontal stretch for that one. Let's go ahead and take a look at the next guy. It's 1/2. Well, we're going to try and figure this out as, okay, what is 1 over 1/2? Well, that's simply going to be 2. So everything's being pulled away from the origin by a factor of 2. Let's go ahead and zoom in on this one. So, here, of course it's going to, 2 times 0 is 0, so that's why that's there. We're going to take a look at this point now. That's going to be, double the distance. So that's going to be about, we'll put it right there. And then now we're going to look at this point down here. Again, that looks like that's right at the 1, so the new point's going to be at -2 out here. And now we simply connect the dots. And note that all the points are being stretched to the left and to the right, but vertically they're staying the same. Alright, so here we've got, again, the original function that we had before. We've got, for our function, b times x. Note right now b is at 3, so everything's being scrunched in by a factor of 1/3. As we bring this in, closer and closer. I have this little x here, so you can kind of have a visual where we're at. That 0.9 relates with that. And as we bring it, out, as the b becomes closer to 0, note that we're stretching it out further and further. And when we get really small, how it becomes very large. As a matter of fact, when b is 0, it just all flattens out. The horizontal stretch factor is becoming nearly infinite at this point. Actually, probably shouldn't even be graphing this because the stretch factor is 1 over 0, which, as we all know, is undefined. But it's just the computer doesn't know that, and so it's just doing an estimate. So it's we're kind of breaking the system right now by leaving it at 0. But notice that whenever it's negative, it causes it to let me get it right at -1 here. Right, we notice we've got a reflection going on right here. Cool. And so, and as we go further out, note it's getting scrunched and scrunched, but it's being scrunched over here on this side right here. All right, so let's go ahead and take a look at all of these together. All right, and just to kind of keep things simple, we're going to keep everything positive so that you can just kind of see what's going on a little bit better. Alright, so right now, let's keep this. Let's keep this greater than 1, actually. So that way it's always being scrunched in. And so I want us to kind of see what's going on here. We got a horizontal displacement going on right here. Note this is important. The stretch factor is outside of both of these terms, right? So if you want to figure out what the horizontal stretch, you would have to factor out the b to know what you're actually what you should be stretching by. Because if I'm sorry, not stretching, like shifting by. Because note that if this were fully written out, it would look like this. We'd have b times x minus b times h naught, like this. And so, keep in mind, when you're looking at this, this would be like a number times x, and then you'd see some different number right there. And so if you have it like this, you have to factor the b out as it is expressed here to know what your horizontal displacement is going to be. Alright, you can figure out what your stretch factor is just by looking at the number in front of x, but you will not know what your shift factor is because it'll be multiplied by your b. So you want it to look like this in order to tell the full picture. Alright. So back to this. And let's go ahead and put back our virtual axis that we were using before. Okay, so let's go ahead and shift the axis around so you can kind of see that now our axis is shifted. Well, let's move it right here. Now let's see what happens as we stretch it out. Note that it's being stretched in and out based on the original, our virtual axis that we've created over here, right? So whenever you're graphing these, the first thing you do is you shift the axis over, and then you start doing your stretching or shrinks. As a matter of fact, it might be worth it just to kind of further illustrate this by just having the other manipulation all by itself here. In this case, that is simply this guy. Now this is just the function being shifted over. Left and right, and then as we can kind of see how it's being moved off of this. Alright, so again, first you shift it, then you stretch it. That's how this goes. And now we're going to go ahead and look at what happens on the vertical side. So first, let's go ahead and take a look at y equals our function plus our k0 value. All right, that's our shift. All right, so now we're going to go ahead and shift this k0 value around. You can kind of see it's behaving the way we expected to before. Now let's include the horizontal, the vertical stretch as well. And we can see, there it is. It's being stretched based off of this new axis we've created for it. So it's, no matter what happens, it's always kind of going off of that axis. And note, I've restricted A to be in between 1 and 3, but we didn't have to do that. That was just for aesthetics that we have it right there. And then note that as we move K along, it doesn't matter. It's always being stretched based off of that new axis that we've drawn. Alright, so let's go ahead and put everything together. Okay, so now go ahead and note how we've set this up. This is just a function being shifted horizontally and vertically, and this is the function when not only is it being shifted, but it's also being stretched. And looks like I go ahead and include that in right there so that we have everything included. There we are. Okay, so this, once again, this is the function just being shifted. This will be the function not only after it's being shifted, but also after the vertical and horizontal stretch here. All right, so first let's go ahead and just move it around left and right. We're just going to shift it. Right, it goes left and right as we are accustomed, and then up and down. Note how that the new axis is just moving right along with it. And now we're going to go ahead and add a little stretch here. Note it's just moving, being stretched vertically, and it's always being stretched in relation to the new axis. Let's go ahead and bring this back to 1. And let's go ahead and look at the other direction. Again, it's being pulled out and then pushed back in towards the y prime axis, the new y axis. And it's always, you shift first and then you stretch. And let's go and take a look at everything going on at the same time. And you have this. And so note that everything's in relation to that new axis. So when you're trying to really see what's going on, it's worth it to just draw the axis first, draw the shifted function, and then stretch it, and you'll have a really good idea of what is going on with the function. Okay, so I think I've given you enough to chew on for this video. Go ahead and make sure you try the homework, and we will finish off the rest of this handout in the next video.